there a lot of residential systems were built up, but now really we come to a bottleneck also with the deployment of the renewables. Efficiency requirements will also go up at some point, and so new technologies like silicon carbide might move in, or already part of it, especially in commercial systems. There might be a higher semiconductor content in there also to really squeeze out more efficiency or energy.
This is the podcast for engineers, the podcast you just have to listen to if you're interested in what's going on in the semiconductor market. Today, I'm joined by Marco Werr, who is the application manager for utility and commercial energy storage systems. And today we're going to be talking about ESS, energy storage systems, and how they can support the green energy transition. Marco, thank you so much for being here.
Yeah, thanks for having me here.
Great. So this is our first episode on ESS.
That's right.
Actually. So we're going to come at it from the top. So let's paint a picture. Let's set it up. What is the current situation with energy storage? And everyone's focused on generating green energy, but how do we store it?
Yeah, that's actually the problem, right? So we forgot about that in the last year. So we built up a lot of solar and wind installations, and now we see that we need to store it somehow in order to keep the prices down also of this renewable energy. Yeah, and what we can say is that or what we see in the market is that installations they doubled since last year, and so the market is really picking up, and a lot of traditional EV companies they're changing also to energy storage and seeing their big business behind that.
So we're talking about generating energy through wind or through solar, but when the wind isn't blowing and the sun isn't shining, we need somewhere to store it. How does this actually work from a physics standpoint?
Yeah, so technology-wise, there are a lot of great inventions, I would say. And if you want to segment it, I would say do it by the principle behind that. So electrical storage, electrochemical storage, mechanical storage, or chemical storage. Yeah.
Mm-hmm.
And going behind this, so this means electrical storage would be capacitors in the end, often used for really short time storage. And then you would also have the chemical storage, so that would be methane or hydrogen.
Mm-hmm.
Probably better for really longer storage times. And then you have the mechanical storage, so for example pumped hydro storage or flywheels. And then the electrochemical storage in the end, so batteries, mainly lithium-ion batteries.
Okay, and you mentioned that some of them stored energy longer, so that's basically the decision-making criteria for going with a type?
Yeah, in a way. So there are some hard and soft factors, I would say. So each technology has its caveats, so that for the duration of storage and also the power needed during that time, it's optimized in a way, or it makes economically sense.
Mm-hmm.
And we see that for the requirements of the integration of the renewables, that mostly the batteries here and also their commercialization with the falling battery costs make the most sense here. So duration times or storage times of 2 to 8 hours, I would say, is here the main use case.
Okay, so what is the status quo right now? What are we as people using for energy storage at the moment?
Yeah, so if we look at all the technologies in market reports, we see that in 2022, I think most of the storage types were pumped hydro storage, so 87%, then some exotic storage, and then the 10% battery storage.
Mm-hmm.
But this changed, I think, last year. So the battery storage really got a bigger share here, so about 30%. And the technology used here is mainly then lithium-ion batteries and for energy storage, lithium iron phosphate batteries.
Okay, 10% to 30%, that's a big jump in just a year or so. So what are some of the reasons for going with battery energy storage over the others?
Yeah, when you look at the factors, so hard and soft factors, the batteries, they got cheaper so it becomes more affordable. Also, the energy density is quite high for the batteries, and soft factors are maybe also time to market. So we see now that we need to build up the storage capacities quickly in order also to deploy the renewable energies to reach the net zero targets. So you can build those containers, put in the batteries and everything, and then just deploy them on the field. So it's not just, it's also some EPC work ongoing there. But yeah, it's probably also higher accepted than building a pumped hydro storage, where this has to be on a certain place. And also the social acceptance might be not given always.
Okay, yeah, makes sense. It seems like it would be a lot easier to place some big battery somewhere than to build a whole system for hydro pump storage. So how are we using battery energy storage systems today? How do we differentiate between different types?
Yeah, so the easiest thing is to differentiate between the use cases. And so we have front of the meter installations and behind the meter installations. Behind the meter installations, probably everyone knows about them. So if you have a solar or PV or on your roof at home and you want to store the energy, then you have that. So that's a residential energy storage system. And then if you go higher with the capacity and also the power range, you go to commercial and industrial. And this is kind of a gray zone. So sometimes they're connected to the grid, but sometimes also, for self-consumption.
Okay, so like an independent mini grid, microgrid.
Yeah, exactly. So if it's for self-consumption, you would say it's behind the meter, and otherwise it's front of the meter. And then if you're front of the meter, you have some attractive business models at the moment where you can just like store the energy when it's cheap. So when there's an oversupply in the market, and then sell it when it's expensive. So that would be energy arbitrage. But also some other services are needed to stabilize the grid here, frequency regulations, such.
So behind the meter, you said, was more residential things for your own home, but front of the meter, I expect a lot of businesses. There's a lot of commercial applications, a lot of demand for this kind of setup as well. Yeah,
so in the last few years, a lot of residential systems were built up. But now really we come to a bottleneck also with the deployment of renewables. So businesses, there's a lot of system integrators right now providing this battery energy storage containers for commercial and utility use cases. And we expect also this market to grow much stronger in the future. And I think global installations we expect to or when you look in the market reports, there will be 1.5 terawatt hours probably installed capacity by 2030. Yeah.
Okay. You mentioned, we mentioned this earlier when we were talking about social acceptance and what an actual energy storage facility or installation looks like. Whenever I picture it, I picture a bunch of shipping containers lined up next to each other. There can be several or a couple hundred. But what is actually inside these containers? Because they're usually closed. You don't really see much from the outside.
Yeah, that's true. But there's quite a lot of value inside, I would say. So mainly, the main part of these containers is, of course, the battery. So you start with battery cells, and then you put them in series to increase the voltage here, probably going up to 800 volts or so. And then you put those cells in series. That forms often a module with 16 cells or so. Then you have a battery management system controlling that module. And then you put them in racks. And those racks, so one of those racks could be then a commercial installation. And if you have several of those racks and put them into a bigger container, 20 or 40 feet container, you have a utility system. And then you have the power conversion also inside, either on the rack or on a central level. So it can be part of the container, but it can also be separate.
Okay, this reminds me, we just did some episodes about AI and data centers powering AI. It reminds me a little bit of this data center setup, a cell and a module in a rack in a container, just the bigger and bigger setup. What is actually, it seems like a complex system of building blocks. You mentioned already battery management. Are there any other technical systems involved?
Yeah, so the two major functional blocks of the systems are the power conversion system. So that is AC to DC or DC to AC, so it's bidirectional power conversion because the batteries, they only store and generate DC voltage. So you need to transform that. That can be then also, there can be some optimizers so that DC-DC optimization is done here. And then you mentioned the battery management system, which is a big part also, especially when you work with the lithium-ion batteries. So you need to operate them in a safe area. Voltage has to be in a certain range for them. And then you have some other functions like thermal management. So there's an HVAC system usually built in. So either air cooling or liquid cooling, and then either of the batteries only or also of the power conversion. And of course some safety functions like disconnectors, fire extinguishing equipment. Yeah.
Okay. What are some of the challenges then when we look at the technical system?
Yeah, so the one challenge is that there's quite a broad range of power classes. So from commercial to utility systems, you start from about 30 kilowatt to several megawatt. And so each system needs to be designed in the end for the use case, but also optimized also on the size.
Okay, so even taking residential out of the equation, you still have a huge range of different variables. Okay.
So that is on the power conversion, but also on the battery management side, because it needs to be cost effective also, such container. I mean, the battery is also already a major part of the cost, but the other costs, we want to keep them small as well,
Is there a lot of standardization in the space already?
No, not yet. So this is also a problem. So each customer probably has their own design. It's usually the case because you want to differentiate, but this also makes it hard to get like the perfect design here. And also they're still evaluating to go, for example, to higher voltages also. And so designs are still changing.
Okay. When you're looking at the system, there's a lot of different aspects probably. It might be different for power conversion versus battery management. But what are some of the aspects that our customers are looking for in terms of semiconductors? What qualities?
Yeah, I think one major factor is the reliability here, because such systems, they run like 15 to 20 years or they want to run them so long. And safety is also a big concern here, especially with all the batteries inside. And also the accuracy of the measurements. So this comes down often to the BMS. So you need to estimate the state of charge of your batteries, so how much energy you have left in them. And over the time, this drifts a bit. And so you lose a bit of money in your business case in the end. So you need to make sure that the components you use, that they have some kind of internal accuracy measurement system to have over long time reliability.
So initially, of course, then it's the safety of the things so that it doesn't overheat, the battery system, the energy storage system doesn't overheat, but actually it can come down to money, wins or losses with energy for accuracy. Okay, interesting. And you mentioned that these systems are intended to last at least 10 years, hopefully.
Yeah, even longer.
Okay, hopefully, at the minimum. And what does the future look like? What can we expect in the next 10 years? When today's systems are phased out, what do we expect the next systems to look like?
Yeah, so higher power density for sure. So I think battery manufacturers are always working on higher power density cells. So this translates also to the power conversion system. So the components need to handle the higher power at the same size or even at smaller size. And efficiency requirements will also go up at some point. And so new technologies like silicon carbide might move in or are already part of it, especially in commercial systems. And then also battery technology might change. So we have lithium-ion battery since a while, and there's some optimization been ongoing. But the prices, I think they might not fall as they did in the past anymore. So we kind of reach a line now or a point, and so there's probably new battery technologies like sodium ion and so on approaching, and to use them efficiently, there might be a higher semiconductor content in there also to really squeeze out more efficiency or energy of them.
You mentioned the battery life, and we know this from our phones probably, that sometimes the batteries aren't quite as efficient as they used to be, but that doesn't necessarily mean that we should throw them away or recycle them.
Yeah.
Is there an opportunity for these big applications for batteries to reuse?
Yeah, for sure. So there are already some companies working on that to use a second life, or to use batteries in a second life application such as energy storage. So they usually then have 80% state of health left the batteries. And this also comes down then to system design. So for the second life batteries, you would probably choose another system design on the power conversion and so on. And I think we will see more on the second life in the future when the electrical cars are then like the second generation has been bought by customers. And also with regards to recycling, I think the EU is introducing also the battery passport.
Battery passport.
Yeah, right. Which is relevant for the energy storage batteries. And here you need to log the data from the BMS, and it so also no one should be able to touch the data in a way or to modify it. So you need to make sure that there's some trust system behind that. And
so just like a passport verifies our identity, it would also verify the battery, where it's been.
Yeah, the where it's been, or where the material is coming from, and how is it used also. So it needs to write down the data of the battery during the lifetime, so it can be used then for second life applications. Yeah.
Okay. It's really interesting. Is there how we're using battery energy storage systems to achieve these decarbonization goals? Is there anything else that customers are looking for when it comes down to a component level when increasing their sustainability efforts? Yeah,
the product carbon footprint, I would say. So in the end, this also comes down to this battery passport, that for the BMS or like battery components, at some point you need to show the footprint data of that. And I think Infineon, we already started in doing that also. So this can really benefit then.
The product carbon footprint, just for our listeners, we provide data for transparency on how much carbon emissions are emitted through the production of our products.
Yes.
And so this is also something that people are looking at when thinking about the footprint of their whole system. You have to think about it at the component level.
Yeah.
Right? Okay, great. Well, Marco, thank you so much for being here. It was really interesting to get an intro into battery energy storage systems. I hope we can touch on the topic again in the future.
Yeah, thanks for having me here.
And to our listeners, if you're interested on battery energy storage systems or what's going on in the semiconductor industry, please stay tuned for future episodes.